welcome to a new edition of the Heat Treat podcast. Today we're going to be talking Austempering and Martempering. We have Steve Metz, which is Vice President of Business Development for Alberts Technologies, formerly Applied Process. First of all, how's it going, Steve? You share with me that there's some warm weather in Wisconsin, so just would like to say hi and how things are going over there.
No, things are great. It's a great time in heat treatment and metals manufacturing in general. And of course, as you had mentioned, Wisconsin today, we're at 93 degrees Fahrenheit, which is lovely weather to be working at a heat treat. I actually get to work from my home most days, but we get about 14 days of warm weather per year in Wisconsin, so this is one of them. But things are good in life and in metals manufacturing in general right now.
Well, Steve, before we started, I want to have this question answered because recently there was a merge or an acquisition for Applied Process, which was a formerly family-owned company, and right now I believe it's part of a bigger group called Albert Surface Technologies. I'm not really familiar with all that. So can you please give us, first of all, an introduction of who you are, what do you do, but also a little background of the group you work for right now, so the audience can understand the type of companies that you're representing right now.
Certainly. So let's start with the Albert Surface Technologies Specialized Heat Treat Group that has been recently formed. And, as you mentioned, Applied Process has been around for many, many years, started by the Keogh family. And then in around 2014, Chip Keogh, he has 3 kids. None of them were involved in the company, said it was time to sell. So he sold to good private equity, and they grew us from 2014 to 2019. And then it was time to sell us again. And Alberts, which is based out of the Netherlands, purchased us in 2019. And we still kept our Applied Process name for a period of time. But then in 2021, they acquired Premier Thermal, which is also a US-based company, heat treater. And they also already had Ionic Technologies. So that we had critical mass. Now we have 3 independent heat treaters that are now going to come together underneath the Albert Surface Technology brand name. And that is in process right now. So we're slowly going through the rebrand. And every once in a while, I still say Applied Process because I've been with the company for 11 years. And slowly it's being reprogrammed. But, and it's really cool because so I've been with AP for 11 years now, Alberts. You have to always remember that. And over those 11 years, the legacy Applied Process, all they did was molten salt quenching, Austempering and Martempering. And many of our customers would say, well, why don't you guys get into oil quenching or normalizing or annealing or everything else? The wonderful thing is now is we have a group of companies that offers a much broader selection of heat treatment options besides just what we used to do at Applied Process, which was salt quenching. So pretty unique in that respect.
And I have been in those plants, Applied Process. They're very well designed, very well taken care of. But yeah, I totally agree with your statement that Applied Process was the specialist on Austempering and Martempering, right? But when you have that infrastructure with that level of quality, staff, lab, maintenance, which is very important in the heat treat industry, you also want to, you can easily grow to the different processes. You name it, oil, which is, there's the stigma, or maybe it's true that it's very hard and even dangerous to actually mix those processes because of some fire and safety issues, but you got then annealing or ion heat treatment, which it doesn't have anything to do with safety. So, I'm 100% with you. So there's a bunch of heat treatment processes. What do you see as one of the largest gaps in specification and application of these heat treatment methods, and what you have found to be effective on closing these gaps, Steve?
Yeah, the greatest challenge that I have seen and what I spend most of my time doing is it's really educating the customer. And that might be a foundry, a machine shop, or an OEM, because heat treatment is, I'm not going to say it's taught poorly, but it's not taught at the level that it should in colleges and also in industry and it's in of itself. So, before our conversation here today, I actually, so right behind me, I have all my college books that my wife wants me to get rid of, but I do use them.
I do the same. I do the same. By the FYI, my office is all with my college books. So
Yeah.
I'm with
So
you.
yeah, exactly. And I do use them on a frequency basis. But so I looked at one which is manufacturing processes for engineering materials. And a lot of design engineers will take this course. And this is 1,000-page book. And there's 12 pages that are devoted to heat treatment.
Hmm.
And then of those 12 pages, only 2 paragraphs mention Austempering and Martempering. So it's very slim. Of course, then there's the one that I subscribe to, which is volume 4 of
Yeah.
is heat treat.
I mean, that's a must. If you're a heat
Yes,
treater and you don't have that book, you're missing something very beautiful.
correct. So the right level of education lies somewhere between that first book that I showed that just has a few pages and this 1,000-page book that has 1,000 pages of heat treatments. So it really comes down to education. And back in college, I had really good professors and some that were, maybe there was some opportunity for improvement, we'll say. And the good ones made subjects relatable. Um, I'm a recovering materials engineer. That's what my degree is in. But the thing that I found is, as materials engineers, we have to talk on a much more personable, understandable level to the design engineers and the mechanical engineers that are making the parts, that are designing the parts, because they're going to put a heat treat specification on the drawing. And if they don't understand that there's other stuff out there besides oil quench and temper or induction harden, other things get overlooked, such as nitriding or Austempering or Martempering. So education.
It is education, and I do agree that well, we're in that industry, right? So we bragged about it, how important we are, right? But we're also a part of the manufacturing group. But heat treating, it's a very specialized segment of the industry, right? And the guys that don't know about it, they sometimes they tend to believe that it's witchcraft, right? And it's not. It's not, but and that's the great part about education. When you get a job or you have to have some knowledge about heat treatment or metallurgy, uh, I believe right now the hardest part or the most challenging thing is to educate the new engineer who is coming.
Yes.
As most of the time, there's a guy that has been in the company for many, many, many years and knows all that from empirical, right, day to
Right.
day. Uh, how and you told me, how's the process to start educating a newbie on heat treat when they had just those 12 pages on college,
Right.
and they know, hey, I know something about it, but what's your approach on educating those newbies?
Yeah. So I have actually, I have a great story to tell. So my wife is an interior designer and an accountant. So she uses completely different areas of the brain than what I use as an engineer. But she really is interested in what I do. And when I worked in the foundry industry for the first 20 some years of my career, I could take her to the foundry and I could show her the pattern. I could show her the sand mold. I could show her the molten metal being poured into the mold. And then we could go down to shakeout and she would see the part, like a fire hydrant or a crankshaft or whatever it might be. Uh, Um, but then when I switched to heat treatment, she said, "What do you do?" And I said, "We rearrange atoms for a living. We change the atomic structure." And she said, "Okay, what do you mean by that?" And like a good materials engineer, I started going through the periodic table of elements. And I said, I got to carbon, and I said, "Okay, here's a good one. Carbon has different crystal formats. So if you have hexagonal close packed, you get graphite. It's soft, it's dark in color, it's got good lubrication properties, and that's one crystal structure. Then I said, if you apply the correct heat treatment and time and temperature and pressure, you can change it change carbon to the diamond cubic format, which has got a completely different set of mechanical and physical properties. It's the hardest substance known to man. It's essentially clear. And I said, so all we're doing in the world of heat treatment is creating a preferred crystal structure. She got it because she told me that her favorite crystal structure and her preferred crystal structure for carbon was the diamond structure. So she understood.
Right. She was giving a hint.
Yeah, and so that's what it's, it's making metallurgy and material science understanding and common. It's putting things in terms that others will understand.
Fantastic. So this was a great introduction, and now let's go into the subject of the day, which is Austempering and Martempering. When we hear these words, I mean, it's what I envision, because I'm not an expert in any subject. Salts comes to my mind, like you're gonna quench some salts, and we're gonna talk about bainite and martensite. Would I be correct?
You have to add osferite in there too in the world.
As well, okay,
Yes.
that's right. But basically, correct me if I'm wrong, but martempering is very similar to austempering, except that the part is slowly cooled through the martensite transformation. And I would say, like, the biggest advantage of martempering over the rapid quenching is that there is less distortion and tendency to crack. Will that be accurate?
Absolutely.
But that would be enough for me, because I don't do that treatment. But why don't you give us like an introduction to each process, how they run, pros and cons of each, maybe some applications, so we can actually wider the universe of the viewers when we say austempering and martempering.
Right. So let's start with some of the fundamentals. When most people think of heat treatment, they automatically think of oil quench and temper or water quench and temper. And in the world of austempering and martempering, we quench in salt. One of the things that people think of automatically is they're just like, well, how can you get the parts down into the salt? They think it's solid, but it's molten salt. It's usually they're nitrate salts. And in the case of the salts that we use in our quench tanks, they melt at about 310 degrees Fahrenheit. So we're typically using them between 350 and 725 Fahrenheit.
It's like a milkshake, but it's like a salt shake.
It's a solution. It is miscible, and because of that, we can get different structures because we're operating in a different area of the TTT diagram. The last time I checked, at standard pressure, the hottest you can get water before it turns into vapor is 212. Oils, you can go up a little bit higher. There are some martempering oils where you can get into the 350, 450 Fahrenheit range, but that's still below the martensite start temperature for many materials. So, let's just take 4140 steel. It's got a martensite start temperature of 610 degrees Fahrenheit. So if you quench in oil or water at a lower temperature, you're going to form martensite. Well, we can quench at maybe 620 degrees Fahrenheit.
That same 4140?
That same 4140. We can. So what we do is we take a look at the martensite start temperature of the material. We custom design a process based on what the customer wants, be it the hardness, be it the mechanical properties. And so we're able to do things in molten salt that you just cannot do in oil or water. And that's the wonder of this process. Because if you think about, in normal heat treatment, you raise the hardness to increase the mechanical properties, but what you give up is toughness and elongation. Those come down. They're inversely proportional to each other.
Also, I would like to add, and the thermal shock is much at a much more higher temperature, and so there logically will be less distortion. Will that be a correct assumption?
That is correct. We have seen, I'm going to say, 75% less distortion or greater than would be typical in oil or water quench and temper. And I'll give an example. We have a customer that approached us a number of years ago, and they had a drive shaft. It was 18 inches long, 3/4 of an inch diameter, 4140 steel. And they were trying to get it to 45 to 50 Rockwell C. And they wanted to hold the runout on the shaft to within 5 thousandths TIR. And they were oil quenching, and they could not hold even 30 thousandths of runout. We were able to take that same part, Austemper it to 45 to 50, and maintain that 5 thousandths of TIR, that run out on the part, which was it was it was a showstopper. And I'll say that about 40% of the parts that we process come to us pre-machined. They'll come in the doors and they are finished machined. We heat treat, we Austemper them, we Martemper them, and they go right to paint and into service.
So my next question will be, which type of steels are reciprocal to Austempering or Martempering, and which are subject to go into oil quench? Because what you're saying is that it's not like it's a superior process, but it has its pros, right? Of course, it has its cons.
Right.
Which are the steels that go to that process, and which are the steels that remain in the oil and water quench processes?
Sure. So any steels that we process and can Austemper, you could also oil quench them as well, and temper them. But let's start with the lower carbon steels. So 10B38, so a boron containing 1038 steel. Just about every lawnmower blade made is made out of 10B38. That can be Austempered. 1050, 1060, 1070, 1075, 1080, 1090, 1095. Those are all great materials for it. 4130, 4140, 4340, 5160, 6150, 52100 steels. So again, we're talking about steels that have higher alloy or hardenability than 1045. So if you're talking 1025 steel, 1030 steel, 1035, 1040, 1045, those are probably going to stick in oil quench and temper or water quench.
But what will that be? What would that be the main reason to stick?
There's just not enough alloy there for us to.
Got it.
We will not form bainite. We will form probably a mixture of martensite and pearlite, depending upon the steel. So if you want to get, and part of that's just the thermal difference. If you quench in oil at 100 degrees, it's not that the temperature gradient isn't as great as quenching in molten salt at, say, 600 degrees. So we don't get as much of a snap right away when the parts hit the quench.
And now let's talk about the equipment. I've seen Austempering or mark quenching run in different types of equipment, right? It can be pits with salts. I seen the UBQA manufactured by AFC, Hallcroft, the Monster, which is a huge piece of equipment, and some other applications which I've seen under atmosphere. Tell us a little bit about how this process is done by its machine, the furnaces, and specifically why the atmosphere is important to be done this furnace. Because I've been in many heat treat shops that they just direct fire it.
Yep.
And then they quench it in salts.
Yeah.
Is that still called Austempering? Or why it's important to have atmosphere in it, and why not?
Yeah.
But I leave it to the expert.
This is an excellent question, and there's going to be several answers to it. So if you think about steels, let's just take 4140 steel, very common steel that's used, and you austenitize that material and open fire first, carbon away from the surface. It's decarbonizing because it's an oxygen-rich environment. So now you don't have 4140 on the surface. You might have 4110 or 4120. It's got a different martensite start temperature. So you could have a martensitic surface in the world of Austempering make sure that you have homogeneous chemistry. 2A is kind of unique as well. That's a furnace variant made by AFC Holcroft, that once the parts go in the front of the furnace, you don't see red hot parts coming out. They are under a protective atmosphere, either endothermic or nitrogen, the entire time that they're in the furnace, and then when they go to the quench tank, into the quench tank. So that's batch Austempering. There are some manufacturers of furnaces where the parts come out of the endothermic furnace into open air before going to the quench tank. So there's that opportunity for oxidation. That's atmosphere to salt. You could do it on a belt, on a continuous wire mesh belt. You could do it in a pusher furnace under atmosphere. The other thing that you can do is salt to salt Austempering. So where you heat the parts either in a chloride high temperature salt or a barium high temperature salt, and then you transfer them to a nitrite salt for quenching and for getting the final microstructure. So there's different variations of it. Salt to salt and belt Austempering are usually used for very thin parts where they heat up very fast, and then you can just dump them into a quench tank. The thickest parts that we've done in atmosphere to salt, 7, 8 inches in thickness. So you can imagine how the parts could potentially oxidize substantially if they're in an open fire furnace. We can also carburize in our furnaces as well, which is kind of unique. So we can.
Well, one question, just one
Yeah.
comment. You told me that some of the material that you get is pre-machined. So oxidation wouldn't be like a bad thing, right? Because they have to post-machine it.
But in the areas, if you think about the areas that don't get machined, so a lot of stuff does get machined coming to us. About 40% gets machined after it leaves us, but they don't machine everything.
Okay.
Usually it's only certain areas. So the area that maybe is not machined now is going to have different mechanical properties if it's decarburized. So that's why atmosphere control is so important in the Austempering process.
You don't want to decarb the parts. Is that what you're saying?
You don't want to decarb the parts, because we want, if you're doing a true Austempering, you want nice consistent chemistry from the surface to the core. And again, I had mentioned a little bit, you can actually carburize in atmosphere type furnaces. So we could 4140 and make it 4180 on the surface and increase the hardness even further, have a bainite surface and a bainite core. So.
And let me give you another observation, and this topic I really like, because when we heat treaters talk about heat treat or the process, most of the time we focus on the heating chamber, on the furnace. But you mentioned it as a snap. The transformation is actually when we're actually quenching. At the moment we're quenching, if we carburize or reduce nitrite or carbonitride, we are absorbing gases into the part. But when we actually really transform the material, is on the quenching phase, right?
Right.
Very, very seldom heat treaters are looking at trends of their quenching or variables. In this case, you do a lot because your heating is very basic. Your atmosphere doesn't have like a boost or a diffusion, or it's very stable because you don't want to carb or decarb. But what are the factors to consider when you are quenching? Agitation, temperature, pH, because that brings a new different subject, which is how to maintain the salts at a premium level. Is that like a big thing to watch every day on your applications?
Yeah, we take samples out of each one of our 17 salt tanks that we have at our combined facilities on a regular basis, and we check for chemistry. We are also one of the interesting facts is we don't buy a lot of salt. We have an internal reclaim process that we use for taking the wash water and then feeding that wash water back to the quench tanks as both a salt addition and a water addition, because
So they're recyclable.
they're 100% recyclable. Correct.
That's a big pro right now with Go Green, right? Because oil is not.
Correct. Yeah. So it's 100% recyclable, but then, one of the unique things that people will say is, well, if your salts first melts at 310 Fahrenheit, how can you get water into it? And actually the salt has an affinity for water. So the salt molecules will actually pull in water molecules. And then when the red hot parts come in contact with the quench salt, it gets released as steam. So we get a very rapid cooling the moment that it first hits the salt quench.
And now let's talk about the popularity over the years. There was a big boom, yeah, in the 90s. Then, and I'm talking about America, right? There was also, the vacuum furnace thing, then nitriding, and right now seems to be that salts are like in the spotlight. Austempering is back on the spotlight. What do you think that's due, or how was the the industry evolution, and where do you see that it's going right now?
Right. So let's take a look at it in a couple different ways. So there's the ductile iron side of things. So Austempered ductile iron, which is about 60% of what we process. And we're starting to see people want to take castings to an elevated strength level and thin them out. So it's all about lightweighting nowadays. And how do you make something lighter? Well, you make it stronger so that you don't need as much material to do the mechanical work. And especially in the light vehicle and the heavy truck marketplaces, there's a lot of interest in Austempering because of the mechanical property advantages. You can take as-cast 805506 ductile iron, which 80,000 tensile, 55,000 yield, 6% elongation, and austemper it and double the tensile yield and actually increase the elongation at the same time. That's something that normally doesn't happen in the world of materials, where you can increase tensile and yield and elongation and toughness all at the same time. So I think people are expecting more out of the materials, and that's why. Now, the other side of it is people are starting to look at total cost. And if you can harden a part and have 75% less distortion, that's all that much less machine stock that you have to leave on the component as well. So I think there's multiple things that are going. We're demanding more of the materials, plus we want to reduce total cost, not just the heat treatment cost. People are starting to look at it from we have a customer that makes bearing components, and for them, it's not the cost of the heat treatment or the price of the heat treatment. It's how much material they have to remove from that bearing race at 60 Rockwell C, which is very difficult to do. So,
and also as a colleague of yours, myself, I try to give that argument to a lot of buyers, right? But they don't seem to understand all the supply chain. I mean, they just see cost of heat treat.
correct.
And it's a very interesting, battle, right? Because you can have buyers as customers that they just see heat treat, but you have to get like a manager involved, that he's gonna take a look at. You're gonna spend less raw material. You're gonna spend less scrap, even logistics, right?
Mm-hmm.
But that's a hard one when your buyer is not educated. And I know that you work with a lot of castings and foundries companies, but I don't, heat treatment will not be their area of expertise. That's why they actually hire you. How do you work, shoulder to shoulder with your customer, because you have an end customer of yours, right? But you have to triangulate it to educate the final customer. How do you do that? Can you give an advice to people that are dealing in the same way? Because your company has been very successful doing that.
Right. What we've done over the years is we've shifted to a model where we really are focusing on the OEMs and educating the OEMs and helping them with their designs, without actually doing the design ourselves, but we'll be there to support them as much as possible. But usually as a heat treater, we're tier 2 or tier 3 or tier 4. We are almost never tier 1. And so we need to talk to the OEMs to make sure that we get specified, or that they specify things correctly. And then oftentimes what the OEM will do is they'll ask us, well, what foundry or machine shop would you guys recommend? And we'll give a list of places that could make the part. And I'll tell you, when a foundry or machine shop gets a recommendation and they get an RFQ because Alberts, or the former Applied Process, gave somebody their name, that is golden.
It is. It is
Yeah.
totally. And you get a commission of that, right?
We get to supply the Austempering or Martempering.
Right.
But it's, as in the world of metals manufacturing, we all got to stick together. We need to work arm in arm. It's, to your point of that triangulation, it's working with the OEMs, the foundry if it's a casting, and the machine shop, to really get the cost to a minimum.
So I got a question really quick. Also when we talk about these processes for the big parts, right? We talk about the monster parts, and,
Mhm.
they come from castings, big foundry parts. This is like on heavy truck construction, even for agricultural equipment. But when we have the oil and gas industry, we have the automotive industry, and the aerospace industry, and the defense, right? Is there like a specification? Because Austempering is a very specific process. It's not like a common oil and quench heat treatment. I don't know if you're knowledgeable of CQI9 or
Yes.
those type of specs. Is there like a CQI9 special consideration for Austempering, or that's covered for the whole heat treatment assessment?
So all of our facilities are CQI9, and
Which is automotive.
It's covered. It's covered.
That's
underneath.
covered, right?
It's covered underneath that. Correct. We could actually, there was a period of time where in one of our facilities we were NADCAP, and it was, we had to make a decision because of the high cost of NADCAP. Do we maintain that, or do we let that go? And the thing is, in the aerospace industry, that we're talking about materials, a lot of stainless steels, titaniums, and aluminum, which Austempering doesn't apply to any of those. Really, where we found that Austempering and Martempering is in braking systems and landing gears. That's it. That's pretty much where it's at.
Where you need strength,
Exactly.
when you need muscle, right?
Exactly. Right.
All right, got it. Steve, it's been fantastic talking to you about these both processes. If there's something we missed or you would like to add regarding our conversation.
I just want to circle back to the educational side of things, for either the young folks that are coming into the heat treat in the foundry industry, or for those that are dealing with customers on a regular basis. It's really about educating them and talking to them in terms that they can understand and make it easy. Heat treatment and foundry should be easy. And, once we've gotten to that common denominator, the rest of the process just goes so much smoother, and involve everybody in the supply chain. We have seen it several times where the heat treater isn't involved, and there's something happens either because we can't support the part or whatever, or there's a hole in the part and it's going to hold salt during the quench process. Get everybody in the supply chain involved. It just goes so much smoother in situations like that.
Thank you so much, Steve. Steve, it's been all right talking to you. Very knowledgeable. You're a very passionate heat treater. I can tell you that. You can look from a mile away that you love what you do. And so,
interesting little fact. So I am, if you look on the introvert extrovert scale, I'm actually a 95% introvert, with the exception of when it comes to heat treatment and metals manufacturing. And then I become a complete extrovert.
you were wild. You were wild when you talk about heat treatment.
Yes.
That's fantastic. Steve, we have talked about binite, martensite, austerite, temperatures, you name it. But at the very end, it all comes to communication skills, personal development. Uh, you've been in the industry for quite a while. You're responsible for the business development of a specific niche for a big company right now. But there was one time young Steve Metz that didn't know as much as you do now. And you were a young engineer, right? Materials engineering. What would be something that you would have loved to be advised, like by a mentor or by somebody with way more experience? What would you tell this new guy that wants to get a job, that is applying for a job on heat treatment, and he just have read 12 pages in college, and he's gonna discover a whole new world, not to say a universe of opportunities? What will you share with that guy?
I had some really great mentors and coaches early in my career, and one of the messages that was very consistent was get your hands dirty, get into the process, take all that book knowledge that's back there and understand how it happens in the factory, in the foundry, in the heat treat, in the machine shop. I'm a materials engineer, but I'm not a white lab coat materials engineer. I'm somebody that I love understanding, getting in deep into the processes to understand what's going on. And in that, what you learn there is expanded on 20 times, 100 times, when you actually get in and understand how it works in the real world.
So get your hands dirty. You heard it from Steve Metz.
Absolutely, yes. I still remember when I interned in the foundry. I think I still have calluses on my fingers from polishing metallurgical samples. So, 31 years ago.
The father of the Toyota way, Mr. Toyota, I don't know what's your first name. He used to say that if an engineer didn't have his hands dirty, he wasn't worth it, right? And because that's right. I mean, that's the way to learn stuff, right? To be very hands-on. Thank you so much, Steve. It was a pleasant conversation. I hope we see each other soon on a live event. Now that COVID is a little more over the past, I'm pretty sure there's going to be like a heat treat show or expo this year. I'm pretty sure people are eager to do so. So thank you so much, Steve. So you hear from Steve Metz, Vice President of Business Development from Albert Surface Technology. We had a great conversation regarding Austempering and Martempering. And I just would like to remind the audience that we are uploading monthly podcasts, not weekly. Now, monthly podcasts. We're on LinkedIn, YouTube, Spotify if you don't have the video capability. And we'll talk to you next time on the Heat Treat Podcast.